So we may now forward to another topic under electrochemistry or electrochemical energy, which is the standard electrode potentials, or what we call, or sometimes we call it standard voltages. Okay, so the driving force behind the spontaneous reaction in a voltaic cell is measured by the cell voltage, which is an intensive property. So it is independent of the number of electrons passing through the number of cells. And cell voltage depends on the nature of the redox reaction and the concentration of the species involved. So therefore, the standard cell voltage, or E naught, is also referred to standard voltage for a given cell is that measured when the current flow is essentially zero. It is where all ions and molecules in a solution are at a concentration of 1 molar and all gases are at temperature or up at a pressure of 1 atmosphere. So we should take note of it. Pag sinabing standard cell voltage, all ions and molecules should be at a concentration of 1 molar and all gases are at a pressure of 1 atmosphere. So if the concentration is not 1 molar, then we will use, or there will be another topic for that, and we will use another equation. Okay, so here the example is zinc plus 1 molar aqueous of hydrogen will yield to zinc 2 plus aqueous and 1 molar plus hydrogen gas, which is 1 molar as well. So it has, basing on this equation, it has standard voltage of positive 0.762 volts. So any redox reaction can split into two half reactions, an oxidation and reduction. It is possible to associate the standard voltages, standard oxidation voltage and the standard reduction voltage, okay, with the oxidation and reduction half reactions. The standard voltage for the overall reaction is E naught, which is the sum of these two uh, quantities. So the standard voltage, the overall, okay, is uh, standard voltage, standard oxidation voltage plus standard reduction voltage. So E naught red plus E naught oxidation. Okay. So we have here an example there. So to obtain the standard voltage for an oxidation half reaction, all you need to do is to change the sign of the standard potential. Standard voltages for forward and reverse reactions are equal in the magnitude but opposite sign. So we have here an illustration. Zinc 2 plus plus 2 electrons will yield to uh, zinc solid. So ang E naught reduction niya or the standard voltage uh, niya ay negative 0.76 volts. But if our equation or our reaction is an oxidation, we will just put the opposite sign. Okay, uh, we will just use the opposite sign. So as illustrated, no, binaliktad, reduction is negative 0.76 and then oxidation is positive 0.76. Again, we have here another example. Copper 2 plus plus 2 electrons will yield to copper solid. So the standard reduction voltage is positive 0.34, while the other half reaction, okay, the opposite reaction, it has standard oxidation voltage, which is negative 0.34. So we actually have here a table. It is actually the standard one. So it says here standard reduction potentials at 25 degrees for many common half reactions. So, ibig sabihin nito, lahat ng nasa table na yan ay reduction. Okay? Reduction lang. So, pag nakita natin na, for example, this one, F2 plus 2E, wait lang. Okay, let's say for example, this one, Fe3 plus 3E or 3 electrons will yield to iron. So, ang reduction niya, standard reduction potential is negative 0.036. But if it is an oxidation, like Fe will yield to Fe3 plus 3E negative. Remember, oxidation dapat nasa product side ang electron. Binaliktad lang natin yung product naging reactant, yung reactant naging product. So, babaliktarin din natin yung sign nitong uh, cell potential, which is, pag naging oxidation na to, it will be positive 0.036. Again, all of these reactions in this table is for standard reduction potential only. Okay. We'll try to answer the following exercises. So we have here an example, letter A. Okay. So based from the table, we can see that we have this for our reduction. This one, makikita to sa table. Plus H2O. So we can see here, andito siya. Ayun. I hope nakikita nyo yung mouse there. Okay. So, based from the table, it has an electrode reduction potential of 1.21 volts. So, basta gamitin lang natin yung table. And the other one is 2I negative I2 plus 2E negative. Nasaan siya? Sa table. So, I2, let's try this one. So, nakikita natin na yung nasa table ay I2 plus 2E. Bakit? Kasi this one is for reduction. And based from our reaction here, it is actually oxidation. So, babaliktarin lang natin yung sign convention. So, oxidation or standard oxidation potential will be negative 0.54. Positive siya sa table kasi reduction siya. Pero dito, since it's oxidation, it should be the opposite sign. Okay? So, for us to determine the standard potential, uh, standard reduction plus standard oxidation potential. So, 1.21 plus negative 0.54. So, standard voltage or standard potential will be 0. How many? 50. 40. So it has 6.67 volts. So we have here another example. 2 sodium plus iron 2 plus will yield to 2 sodium positive plus iron, which is solid, which is electrically neutral. Alright, so we have here uh, an half or a half reaction, which is Fe 2 plus 2E, 2 electrons. This one is reduction. Again, bakit? Kasi nandito ang electrons nasa reactant side. And we have to, so, okay. So this one, base sa table, negative 0.44 volts. This one, di naman siya pwedeng maging reduction din. So, babalik ta rin natin. So, it should be uh, Na plus E. So, reduction na to based from the table. Okay. Ito ay oxidation. So, based from the table, ang value ng standard oxidation potential natin ay 2.71 volts. Okay. So, our standard electrode potential will be standard reduction potential plus standard oxidation potential. Negative 0.44 volts plus 2.71 volts. It will be how many? 2.27